Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
We are live at Kern High School District's Regional Occupational Center. We're going to be exploring the craft of welding and fabrication today and really take a look at what gets made and how math is applied here at the Regional Occupational Center. Joined right now by Assistant Principal Steve Miller. Steve, thanks for having us this afternoon.
Hey, thanks for coming.
Wonderful site. We've been here quite a bit this season. We were here with Kern Schools. We took a look at the robotics program. So tell us a little bit about the welding and fabrication program.
This is one of our shop programs out here, and it's a semester of a welding class where the students learn all the basic welds and techniques, and then the second semester class, they go on to a fabrication class where they apply those things they've learned.
So the ability to metal work and then take it into actually constructing something with some really solid materials, this space allows students to really explore a lot of those concepts at just a very fundamental, foundational level before moving on to some deeper construction concepts.
That's correct. Yeah, so those students that do learn the basic skills and that have all the safety that they need, yeah, they go on to the fabrication class and apply those things.
What's the demand for these skills, especially here in Kern County, as far as welders and fabricators?
Well, fabrication, we do have quite a bit of fabrication in town, and I think that's where a lot of our kids get their initial jobs in fabrication, and then they move out into the oil industry or different industries we have here in Bakersfield.
So then the opportunity to get hands-on very early on in a student's education, I mean, that sets you up with a skill set that you can take just about anywhere.
Yeah, we try to do that with as many programs as we can, set up internships, have kids go out and do a job, internship, and so we try to do that with all our programs. So,
Mr. Miller, this all starts right here in this workspace here. We're also joined by Welding 1 instructor, Bill Bazell. Bill, thanks for having us this afternoon.
Thank you.
Bill, give us a little bit of an idea of the workspace we've got around us here.
This is where we introduce them to the welding industry, or the different industries where welding can apply. We start them with basic safety, and then we teach them basic oxy-fuel cutting and welding, plasma cutting, gas metal arc welding, flux core arc welding, shielded metal arc welding, otherwise known as stick welding, and gas tungsten, TIG.
So the idea here is that you're taking pretty heavy metals and you're finding ways to work with them, cut them, separate them using extreme heat. So there's a lot of safety procedure that you really have to work through in order to be able to handle such extreme conditions.
Yes, sir. Some of the temperatures we deal with in this shop can exceed the temperatures found at the surface of the sun, greater than 8,000 degrees. So definitely safety is a very foundational part of this curriculum.
So when we talk about the curriculum, and we've had a chance to talk a little bit before we were on the air about the kind of math that gets applied into welding at the onset and the kind of operations and calculations that students have to really become familiar with as they explore welding.
Yes, sir. If you're going to work in the fabrication side of welding, if you're just going to be a basic welder, pipe fitting, you're going to look at trigonometry. On the fabrication side, you're going to work a tape measure all day, and that tape measure is going to throw you math problems all day long. Fractional math problems. Sometimes you need to convert your fraction to a whole number and then back to accomplish your goals. So we try to get them started on the basics here as it applies in our industry.
Now, you were telling us about a problem that you worked on here in class today, actually. You had it over on the board here. If you want, we can go ahead and take a look at this, and it might look very familiar, especially when you're in the 6th or 8th grade range and you're starting to look at components of area. So this is a conversation about dividing a steel plate into smaller squares.
We started with the average plate steel comes in 4x8 foot sections. I threw up 1/4 inch thickness. And the first question that we asked was, you have 3 plates that are 4 foot by 8 foot. If I told you you needed to cut 18 inch by 18 inch squares, how many squares can you cut out of 3 sheets? So it's practical math as it applies in the actual work setting.
This is a real problem that welders will have to face. And what's fascinating about something like this are the different entry points you could enter into. You know, we're talking about cutting a square measured by inches out of a plate measured by feet. So what are some of the strategies that you've seen some of your students employ to work with a problem like this?
Strategies, I've seen all kinds, really. There are times where I can follow them because I love to have them come up and do the work on the board so that I can follow along and see what they're doing. I will tell you, there have been times where they're using concepts or math, for lack of better words, math, a process in order to find the solution that I'm lost. I'm trying to follow and going, okay, what are you doing? So one of the things that I commonly tell them is there's more than one way to skin a rabbit. You know, you've got your way, I got mine. But if we are coming to the same answer, we're okay.
We went ahead and posted this on our Facebook feed, so if you want to give yourself a chance to work through this problem and see how you approach it, go ahead and check out our page on Facebook, Do the Math Bakersfield. Bill, thanks for showing us this problem today. I'm just thinking of a lot of different entry points into something like this. You got a great workspace here, and you're doing great work to get kids into a field that needs people, and this is a skill that you could just jump right in on if you have the wherewithal.
Thank you.
So a little bit later on in the program, we're going to move over to the Fabrication Center here at the Regional Occupational Center. Coming at you all afternoon. We'll be right back, and we're going to take a look at how the welding component comes over and joins up with the fabrication. Back here live at Kern High School District's Regional Occupational Center, joined right now by welding and fabrication instructor Scott Trimble. Scott, thanks for having us in the Fabrication Center. Tell us a little bit about the space we've got today.
Well, thank you for having me on. Yeah. As you guys saw earlier, that was the welding one side where the students come in, most of the students come in not knowing anything about welding. So they come in, they learn the basics starting from the ground up. Safety, oxy-fuel safety, then general welding practices. And over there, they do a little bit of building, but over there it's primarily learning how to weld, how to set the machines up, what different welding processes are, what they apply to, and how to use them. Once they complete their semester over there, then they move over for a semester on my side, which is a little bit more advanced welding and fabrication. Now the main difference there, fabrication is on this side, they actually build stuff. They complete projects, stuff that we do here for the school, and also the students can build projects for themselves. As you can see, we have a multitude of projects going on here, so it's something where they actually learn the welding processes plus fabrication, and come with building, that's where they need to start applying math. Even though they don't know they're generally doing it, a lot of it is math-based, reading a tape measure, figuring out areas, figuring out what material they need to order.
One of the parts of that we were talking about with a project that your team is working on right now is scaling. In fact, there's a device over here, a plasma cutter, that illustrates that pretty nicely. So kind of guide us through the plasma cutter here. And we have a plate design that we're working with through the U.S. Marine Corps.
Yes. This is our Lincoln Electric Torchmate 4800 table. This is a fairly new machine to our school here. It is a great tool to have, a great tool for the students to learn on. And as you see over here on the computer screen, we have a drawing, and we could scale in to see it. And also, we could scale this to different sizes. When we scale out the black outline, that's a 4 foot by 8 foot sheet of material. Now, we could change the scaling on this just by coming up here and entering different numbers. So once we get the basic design in, we could scale that from something 0 all the way up to a full 4 by 8 sheet of material.
And we were talking about a 4 by 8 by 1/4 inch steel plate in with Bill Bazell in the welding room, and this is pretty emblematic of that kind of plate, of what that really looks like.
Yes, this is a 4 foot by 8 foot sheet of 1/8 inch thick material, so it's about half the thickness of 1/4 inch, but it's still 4 by 8 sheet. And in here, you'll notice we have a bunch of designs cut out. This in here, you could barely make it out, but that's a Camp Hamilton cutout, and that's going to be going on one of the projects that we're going to see here in a little bit. And this is the finished product. This is how it comes off of the plasma cutting machine. As you can see, it cuts out pretty detailed, not super detailed, but it does a very good job on it. So this is something that we cut out here that we get to use. We use it for in-class projects, as well as students to take stuff home, as well as projects that people come in from outside the school district that they would like us to work on. It's a good opportunity for students to work with people that come from outside the school that, hey, we'd like you guys to build a project. Can you help us with that? And that's what this project is here that we're going to see here in a little bit.
And it lets you really scale in as far as any kind of design. If you have a vision for it, the plasma cutter will be able to punch that out, and no space is wasted. I mean, I could see a few dozen, maybe a couple of dozen of those printed off just on one sheet.
Yeah, and that's one of the things that we teach here is inventory control. Project management is, if we're doing a job for somebody, I teach them, if you're working for an employer and there is wasted material turns into wasted money. Wasted money turns into the employer, hey, we need to do something to kind of fix this. So it teaches them, they got to use the math on how could I nest stuff different? How could we get the most out of our material to maximize the dollar? So a lot of that goes into project management and project design on how can we get the most out of what we have to save the customer money and get the best end product.
So we were talking about this project through Camp Hamilton and the U.S. Marine Corps that your team's been working on. This isn't just some sort of, real quick moonlight project. This is a pretty significant order.
Correct. Yes, it started out just with one bench. Actually, one of our teachers here at ROC, our law enforcement instructor, he is part of Camp Hamilton, and he came up with an idea. And so myself and the students said, okay, we took his vision and ran with it. We said, okay, this is what you want. They would like a bench. He wanted it for a Veterans Day service at Camp Hamilton, and we got it done. We got it done on very short notice, which that helps out also because we made the customer happy and we had a great end result. And something that started out as one project turned into, we have an order for 5 more, and they're talking about an order for another 5 more after that. So the students are kind of seeing, hey, they did a good job, and now customers want, so that's developing a good customer base. And that goes back to, a lot of it's math related. It goes back to how long are we going to cut the material? We want to make all the benches the same. That way one's not short, one's not larger. Make sure it's not crooked. We want everything to look square, aesthetically pleasing, and also utilize the best material management that we can.
I wanted to bring in Daniel here, the 12th grader here at the Regional Occupational Center. Daniel, thanks for joining us. Wonderful work we've taken place here with this bench. Tell us a little bit about some of the work that you've been able to employ with this object today.
Well, Trimble just, he told me how they wanted it, what measurements they wanted it, and he gave me a blueprint that showed the cuts I have to do right here. So there's a 10 degree right here, a 5 degree right here, 5s right here. These are also 5 degrees, 5s on these ends, and 5s on those ends, and then the rest is 90 degrees.
So those add up pretty quickly, and you can see a pretty significant difference between a 5-degree bend and a 10-degree bend.
Yes.
When you're starting to learn about angles, they don't really seem like there's too big of a difference because you're really only working with them with a tiny little protractor on a piece of paper. When you see it out in this scale, I mean, now you can see the difference in double the angle.
Yes, you can. So these are all 5s right here, but when you bump it up to the 10, it's a lot.
You can see it reclines a little bit more. And so that kind of precision to be able to scale and recreate over the course of multiples of the same object, you can tell that there's some consistency built in. Daniel, wonderful work so far.
Thank you.
When we come back a little bit later on in the program, we're going to really get hot and heavy with the welding aspect of it. I understand that I need to get myself prepped and ready to go for that. Back here live at Kern High School District's Regional Occupational Center with welding and fabrication instructor Scott Trimble. We're wrapping things up here in the fabrication room. We were talking with Daniel before the last break. He's continuing to work on some of the work on this bench, and we had a conversation about contraction of metals and how you have to take that into account when welding.
All right, when you're welding, we're using an extreme amount of heat. When metal gets hot, it expands. You're expanding the molecules in the metal. So naturally, you're going to have expansion and contraction. Expansion as it expands, contractions when it cools down, it shrinks. Now, one of the important parts of that, as we look at the project that Daniel's working on, we have a couple of tack welds. Now, these 2 initial tack welds, they're there to hold the piece in place until he could attach a couple more tack welds. Now, it's very important to have tack welds on there because if not, if we just started welding at one end, the non tacked part is going to start moving around, and that could cause a fitment issue with the pieces as we continue to build it. They could not fit right, they could have too much space, not enough space, and the piece could not fit, and that could ruin a project. So Daniel's going to give us a little demonstration here. He's going to put a couple more tack welds onto the piece before he welds it.
And so this is a matter, and you know, you notice the mask as far as making sure that you can see the cuts clearly, as well as protecting yourself. We're going to go ahead and put a filter over the camera as well. But, I mean, the visual of being able to see clearly once you do make that weld is very important, and so the right material for the right job is crucial. And so that has a dual effect. You know, one of the things I noticed as I was observing that is that you can see it melt together as it cools, in addition to just when the initial weld takes place.
Yeah, you could see it as the weld happens. The material in here, the weld is about 5,500 degrees. It almost instantly heats up the metal past its melting point. As it deposits metal in, it welds it together, joins with filler material that comes out of the MIG gun that he's using, and it starts to form the pieces together, starting to form a near unbreakable bond. If it's welded properly, which Daniel's doing right now, it'll be extremely strong. And the weld, in this case, will not fail. If it ever got to the point of its yield strength, the material around it will fail before the weld will.
You know, how many of these did you have to do before you felt more and more comfortable with this? Because this seems like a very terrifying prospect for the average person to deal with thousands of degrees in your hands.
Well, after the first bench, I went through a couple problems I had, but once I got working on the second, this is the third one, I ironed out a lot of the problems I had, so now it's starting to become really easy. So for all the other benches to come, I'll be able to knock them out faster and better.
It's remarkable to hear you say that after the first time you kept going into it, it became more and more comfortable to deal with. That's incredible for me to hear. Just even with the extreme temperatures, how comfortable we grow as people.
And that's one of the things we teach here, not just how to weld and build things, but also about problem solving. They call it soft skills, employability skills, how to help the students, whether they're in the welding industry or not, whatever they do, we're trying to teach them how to be good employees and good people in life, how to solve problems on their own, how to be forward thinkers, and how to get things done.
We also wanted to check in with Josh here, who's got some work on the seat weld as well. Tell us a little bit about what you're working on here.
This is my 7018 structural steel plate test. I'm just running it on a 22-degree bevel on both of these, so it makes it a 45-degree angle in the middle. And I have to run about 5 or 6 passes to get my weld out on these 2 flat plates.
So Josh mentioned something really interesting. The fact that they were 22 degrees, but was going to end up in the 45-degree angle. So, you know, when I think 22 and 22, that gets me to 44. How do we compensate for that extra 1?
It's actually, they're cut to 22.5 degrees per bevel.
And a half. There
Yeah,
we go.
22.5 degrees. But the American Welding Society, you get a variance of about a degree. So they're not, it's not extreme, but it's, when you're looking at here, 22.5 degrees, that's pretty critical as far as the bend. Now what that does, if there's not enough bevel in there, you'll have a hard time filling up the weld. If the bevel's too far open, you'll have to run a lot more weld passes, and the more weld passes, the bigger chance you have for impurities, slag inclusion, porosity. So what Josh is going to do here is he just made the first weld pass, he cleaned it up, he's going to run a second weld pass. After he does that, after he gets happy with how the welds turned out, once it gets to the specification that's listed on the D1.1S certification specification, after that we'll cut it apart, and here in a little bit we'll show you the strips that get destructive tested that we do right here in the shop that will actually certify these young men and women for certified welders in their industry.
And this isn't just necessarily for high school students. Josh is coming to us postgraduate, and so this is a great opportunity for anybody, if you're interested in exploring the welding field, to come on down to the Regional Occupational Center, check out the program. Josh is going to work on that right now, and as he does so, I want to go ahead and again thank the folks here at Regional Occupational Center, Scott especially, for having us today, and as we do with any time we visit out in the field, award you with our Do the Math tile for an exceptional support of our program.
Thank you very much. It was a pleasure having you guys, and thank you for having me.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.